Good day, students. Today, let us derive the system metrics for a thin lens. So, we have seen in general the form of a system matrix. Let us write that. It is given as matrix S is equal to 1 minus P2D by mu minus of P1 plus P2 minus P1 P2D by mu d by mu and 1 minus P1 d by mu. If the lens is of a finite thickness t, we had substituted the term d with t for a thick lens, right? Now for a thin lens, we take the assumption that the thickness tends to 0. Thus, for a thin lens, thickness tends to 0. This implies the system matrix of a thin lens to be 1 matrix form, the second term minus P2 d by mu, in that d tends to 0. Hence, we get only the term 1. The next term minus of P1 plus P2, again the next term becomes 0. Here d by mu becomes 0 and this term becomes 1. Thus, this is the form of the system matrix for a thin lens. In terms of Gauss constants, we get the relation A is equal to P1 plus P2. B is equal to 1, C is equal to 1 and D is equal to 0. Now from the relation A is equal to P1 plus P2, let us expand it in terms of refractive indices and radius of curvature. A is equal to P1 plus P2, that is P1 is equal to mu2 minus mu1 by R1, right? The lens is placed, so we have this thin lens of refractive index mu placed in air. This implies that mu1 is equal to 1 and mu2 is equal to mu. Okay, fine. Thus we get P1 to be mu minus 1 by R1 and P2 to be, for P2, the second medium is air and the first medium is mu. Okay, so we get 1 minus mu by R2. Here, taking the factor mu minus 1 as a common factor outside, I can write 1 by R1 minus 1 by R2. Let this be your first equation. Okay. Now, in terms of Gauss constants, the image plane, the condition for the image plane was obtained earlier as A d1 d2 plus B d2 minus C d1 minus D is equal to 0, right? Now let us substitute the values for B, C and D. Okay. So we get A d1 d2 plus d2 minus d1 is equal to 0. Now dividing this equation by d1 d2, division by d1 d2 implies A plus 1 divided by d1 minus 1 divided by d2 is equal to 0. That is, A is equal to 1 by d2 minus 1 by d1. Now, d2 is actually the distance of the image from the lens. We usually define it as v. And d1 is the distance of the object from the lens, usually denoted by the letter u. Seeing this expression, we can easily identify it as the lens formula 1 by v minus 1 by u is equal to 1 by f. Let it be the second equation. Okay, fine. Now, equating the first and second equations, because both are a, right, we get 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. This is the lens maker's formula for a thin lens. Okay.
Let us go through some problems worked out from the textbook of Optics by Brijlal Subramaniam and Avdhanalu. The first problem: obtain the system matrix for a thin lens placed in air and made of refractive index 1.5 and radius of curvature 50 centimeters each. Hence, the given data is that we have a thin lens and it is placed in air. The refractive index of the lens is 1.5. Radius of curvatures R1 is given as 50 centimeters, that is 0.5 meters. By lens convention, R2 will be minus 50 centimeters, that is minus 0.5 meters. System matrix for a thin lens is written as 1 minus of P1 plus P2 0 1. Here P1 plus P2 is obtained as P1 mu minus 1 by R1 plus 1 minus mu by R2, that is mu minus 1 into 1 by R1 minus 1 by R2. Here 1.5 minus 1 into 1 divided by 0.5 minus 1 divided by minus 0.5. Thus, we get P1 plus P2 is equal to 0.5 into 2 divided by 0.5. That is equal to 2. Thus, system matrix for a thin lens is obtained as 1 minus 2 0 1. From this matrix we get A is equal to 1 by F, that is equal to 2 here. Therefore, focal length of the lens is obtained as 1 by 2, that is 0.5 meters. The system matrix obtained is of this form and the focal length of the lens is also calculated.